Okay, I want to talk about multiplying radicals. If you notice in this problem, I have 3 square root of 48. That means 3 times the square root of 48 times the square root of 98. So if I want to multiply these two together, I'm going to end up having to multiply these radicals. Well, I don't want to multiply the square root of 48 times the square root of 98. I could. I would just multiply 48 times 98 and write out the square root, but that's not the best way to work these. So the best way to work these is to take the square root of 48 and the square root of 98 and break those down. So in order to do that, you should learn your perfect squares. So your perfect squares are the answers to square problems, meaning 1 squared is 1, 2 squared is 2 times 2, which is 4, 3 squared is 3 times 3, which is 9, and so on. Okay, 16, 25, 36, 49, 64, 81, 100, 121, 144. That's 12 squared, 12 times 12. 13 squared is 169, 14 squared is 196, and 15 squared is 225. It will be to your benefit to learn the squares to 15 squared, which is 225. So these are your perfect squares. Okay, what do I mean by that? So let's look at 4. Why is 4 a perfect square? Because I can take 4 and I can break a square up into 4 pieces, and so this is a 2 by 2, 2 times 2, 2 squared is 4, so that gives me 4 units. A 9, it would be a 3 by 3 square. I get 9 units on the inside because 3 squared is 9. So these make squares, okay? So when you take the square root of a square, so when I take the square root of, let's say, of 25, if I take the square root of 25, I'm asking you what were the sides of that square. So the sides of that square were both 5, because 5 by 5, or 5 times 5, is 25. Okay, so that's perfect squares. So in order to simplify these, we have to find a square that will divide into these radicands. The guy on the inside is called a radicand. Okay? So what I usually do is I just take my calculator and I start dividing. So I take 48 and I get a number. The closest to 48 is 36. Okay, so I say, well, does 36 go into 48? Well, no. Does 25 go into 48? No. Does 16 go into 48? Yeah. So if you took 48 divided by 16, you're going to get 3. So I can use the product rule, and it says that I'm allowed to break square root of 48 up into a product, and that would be the square root of 16 times the square root of 3. So now I can simplify that. The square root of 16, so remember I'm saying I've got a square with 16 pieces. What were the sides? Well, the sides were 4, because 4 times 4 is 16. And if I take a square with 3 pieces, that's not possible. So this is not a perfect square. So that means he just stays because he wasn't a perfect square. Okay, so 98. So then I go back to my list and I say, well, did any of these guys go into 98? So I'll start dividing. I'll just use my calculator. So I'll say, okay, well, the closest one is 81. So does 81 go into 98? No. Does 64 divide into 98? No. Does 49 divide into 98? Maybe. Let's try that. Okay, so I can say, well, I don't know, 49 times 2, that's 18. 8 carry my 1. That's 8 plus 1 more, 98. Okay, so yeah, 49 goes into 98 2 times. So I'm going to break this one up. So this is the square root of 49 times the square root of 2. Okay, so this is a perfect, right? So if I'm thinking about it in terms of a square, I've got 49 pieces. So if I've got 49 pieces, it was a 7 by 7. So the square root of 49 is 7. And the square root of 2, that doesn't make any sense because if I had two pieces, it's not a square, it's a rectangle. So this is not a perfect square. Okay, so what I've done now is I've simplified these two radicals right here. So I've got 3 times this. Okay, well, the square root of 48 I simplified as 4 times the square root of 3. So this is 3 times 4 times the square root of 3. And then I'm going to multiply that times the square root of 98. And the square root of 98 is 7 times the square root of 2. I can multiply these guys together now. It's just a big multiplication problem. This means 3 times 4 times the square root of 3 times 7 times the square root of 2. So I can multiply now 3 times 4 times 7. 3 times 4 is 12, and 12 times 7 is 84. And then I can multiply my radicals together. A square root of 3 times the square root of 2 is a square root of 6. And think about that, that's 6 individual pieces, right? And so if I had 6 individual pieces, that's 1, 2, 3, 4, 5, 6, that's not a square because that's a 3 by 2. So it's not a perfect square, so that means square root of 6 stays square root of 6. So the product would be 84 times the square root of 6.